All right, let's start 1-4, measuring angles. We measure angles in degrees. A degree is the measurement around a circle. There are a total of 360 degrees in a circle. Think of the spokes on a bicycle wheel, like this picture right here. So around this circle, if we start at a point on this line and go all the way around, we have gone a total of 360 degrees. Then, maybe if you look at just this little section right here, that might be about 5 degrees or so. It's just a little section of that circle. Next, we've got angles. An angle is formed by two rays that have a common endpoint. The rays are called the sides of the angle. Okay, so right here, we've got ray AB. We don't need to write the word ray. We could also put its hat on there. We also have ray AC that make up this angle right here. This is the angle inside of there. So next then, the other part of the angle we have is the vertex. It is that common endpoint we were talking about. So right here where the rays meet, the part that they share is called a vertex. Interior points. They lie inside of the angles. So H is inside of the angles, so it is interior. Then exterior points lie outside, so point G here is exterior. Naming angles. You can name angles in 3 different ways. You can use a number if given. On this picture, we've got angle 1 right here, and we've got angle 2 right here. So we'll draw something that looks like an angle and put an angle 1. There's also angle 2. The next way is by 3 points with the vertex in the middle. It's kind of like you trace out the angle. So, for example, I can go from point A to point O, because that is my vertex, and then out to point B. So I could call that angle AOB. Notice my vertex is in the middle. So then the other angle could be called COB. Still, point O is in the middle because that's the vertex. You could go BOC, you can go BOA. You can switch the order as long as your vertex is always in the middle. The last way is using just the vertex. You can only do this if only one angle is pictured. So if only angle 1 was pictured right here, then I could just call it angle O. Since there are 2 pictures here with the 2 angles here with the vertex O, I don't know which angle I'm talking about if I just say angle O. All right, we have 3 different kinds of angles. This should be a review. We've got acute angles. Those are angles whose measure is less than 90 degrees. Think acute means small. So we're talking about this one in bold right here. This would be our acute angle because this here is 90 degrees and we are within that. Next, we've got a right angle. A right angle is an angle whose measure is equal to 90 degrees. And this box here is what is always going to be used to signify that this is a right angle. Obtuse angle, an angle whose measure is greater than 90 degrees. So 90 degrees would probably be about right there, so we are a little farther out than that, which would make this a bigger angle. All right, we also have congruent angles. Those are angles that have the same size or degree measure. So if one was 30 degrees, the other would be 30 degrees. And we can use that congruency symbol right here, but when talking about angles 1 and angle 2. We have angle bisectors. So an angle bisector is a ray that divides an angle into two congruent angles. We mark these congruent angles with little rounded angle marks. One for each of these angles means those two are congruent. And then this ray going through here is our angle bisector because it's what split that whole angle here in half. The two angles formed are the same degree. So again, if one of them was 30 degrees, the other one needs to be 30 degrees. Angle addition postulate. This is our last thing. So this means that one part of this angle plus the other part of this angle will make up the whole angle picture. Okay, so if we talk about naming these angles, we would talk about the measure of angle AOB right here. And then we would add onto that angle BOC. And what we would result in is the whole thing AOC. So, for instance, if angle AOB was 40 degrees, let's put that there. This M here means measure of the angle. So we've got one part of it that is 40 degrees. Then we go on to angle BOC, and I say that is 55 degrees. Then I would add on 55 degrees, and how much should my whole angle be? Well, 95 degrees then. So you just add it up to total that whole angle. All right, so let's add on a little algebra into this for the last problem. We've got the measure of angle ABD. So I'm talking about the whole thing here is 130. So a lot of times I like to draw that in so I can picture it on this picture. Find X and the measure of angle ABC and CBD. So how will we start? We'll take part plus part equals that whole. So 12x plus 25. And then I will add on the 8x plus 5 and set it equal to 130 because that's what it said the whole angle was. All right, so now some algebra, combine like terms. 12x and 8x both have x's. 25 and 5 are whole numbers. So we've got 20x and plus 30 equals 130. We subtract 20x equals 100. Now we divide. We are left with x equals 5. Now, are we done? Nope, because it said to find x and the measures of ABC and angle CBD. So I have found x. I'm a third of the way there. Now to find out what the measure of angle ABC is, I will just plug 5 in. So it was a 12x plus 25. So we've got 60 plus 25 is 85 degrees. Then angle CBD we had 8 times x plus 5. So 8 times 5 is 40, plus 5 is 45 degrees. You can double check because 85 and 45 should add up to our total of 130 in the end. That's it for 1-4. Make sure to bring your filled in notes to class.